class, you know, in the last 20 minutes of class or so. Just beware, it is only chapter 5. And so all of chapter 5 questions are the beginning of exam 3, except with the exception of this, which I think is like fall 15, but I don't go back that far. I've tried to keep it to the last several years. I didn't go back to, was that 2015? I didn't go back that far. So, you know, just these first 10 or 15 or so questions on exams 3. Okay? Y'all have particular questions that you want me to look at? All right, Abby?
Exam 3 on fall 18 results.
This one right here?
Yes.
Yeah, what is the work done by the man on the block? So we have friction. Oh, no, so there are 2 questions here. Like, I could be asking what is the total amount of work being done on the block? Or I could just ask, what is the work being done by the man? And if I'm looking for the work just done by the man, that's going to be FD cosine theta. That's all it is. It's just going to be 45 newtons times the distance, which is, that's 5 meters, that's D, times 5 times the cosine of 28. That's not the total work that's done on the block, because the total work done on the block also includes the frictional force. Let's go ahead and find this. So 45 times 5 times cosine of 28. I get 198 or 200 joules. That should be the right answer, right? D is the right answer on that one. But there are other problems where I'd ask, what is the total work being done on the block? And in that case, I would have to have the work done by the force due to the man minus the work done by the frictional force. That's probably what you were doing, that you were finding the frictional force. Yeah, so that means, so this would be 200 joules, and then the work done by the frictional force, I assume, what you found, is equal to 50 joules. Can I just find that just for everybody? Is that okay? Because that does come up in other questions, but it's not relevant here because it's only asking for the work done by the man, not the total work or the work done by friction. But if I wanted to find the work done by friction, first I'd have to figure out what is the frictional force. I know that's mu, which is 0.1, times the normal force. Look, y'all, the force weight is going to be equal to the normal force. So that means that the force weight, you know, is 8 times 10 or 80 newtons. So it's going to be 0.1 times 80, which is equal to 8 newtons. That's the frictional force times the distance. So the work done by the frictional force is equal to the frictional force times the distance, which is going to be 8 newtons times 5 meters, which is 45, but it rounds up to 50. Well, I guess it would be 45. 45 joules. Notice I didn't put in the cosine theta term there. I didn't do that because I know that the frictional force is directly opposite the displacement. So I know that cosine of 180 is negative 1, and that negative will come in up here when I take the difference in those. So that's what you did, and that's why you got the wrong answer. But in another question, I might ask, what is the total work? And I think I do in other questions. That's why you're confused. Yeah. Yeah, sure. Yeah, so here, the work done by the gravitational force, that's simple because once I realize that the y displacement is equal to 0, it's not moving in the y direction, so that means that it's 0. Even though there is a gravitational force, there's no displacement in that direction. So any vertical force for an object with a horizontal displacement, no work done at all. Okay? Ashlyn, I think you had a question, right? Sure. Just beware, there are no free response on the quiz, but yeah, they're still good questions. Okay. Is this it? Exam 21? Okay, yeah, so number 2. Yeah, these questions come up quite a lot, actually, and you'll probably see some similar question. It's a work energy question. I'm pretty sure I had one or two on there. I was going to, label some things. Notice that it does have a frictional force, so it's going to be up the inclined plane. I don't really need to label the gravitational force. Yeah, I don't need to label the gravitational force. I'm just going to recognize that it does have a frictional force. The energy that's lost due to friction as it moves down the inclined plane for part A, well, that work is equal to the frictional force times the displacement. This is a 3, 4, what kind of triangle? 5, so that's 5 meters. So square root of 3 squared plus 4 squared, that's equal to 5. But you're probably going to see a 3, 4, 5 triangle on the test, just know it. The frictional force is 5 newtons times the displacement of 5 meters. So that means I lose 25 joules of energy. That's due to the friction. It takes away 25 joules of energy. So for part B, that's the hard part. As it moves down, what is the speed of the block at the bottom? So it has potential energy up here, and only kinetic energy down here. So what happens is that I start with a certain amount of potential energy. I lose the work that is done by the frictional force, and then that is all becomes my kinetic energy. So I can think about it in terms of an equation like that. I start with this big amount of potential energy. As I'm going along, I lose this work due to the frictional force, and then what I have left is the kinetic energy. So the potential energy is mgh minus the work done by friction, which I already know, that's 25 joules, and then that's equal to 1/2 mv squared. Be careful, I've seen students that would cancel out these m's. You can't do that. You can't cancel the m's because it's not in every term. So be careful. I've seen that a lot in my office over the past week, where students are canceling out m's or halves when they're only in 2 of the terms and not all 3 or all 4. So I have to put in the mass here. That's going to be 10 kilograms times g, which is 10 meters per second squared, times h, which is 3 meters. Be careful too with my displacements, right? So the potential energy, this is the distance that's relevant. For the work done by friction, this is the distance that's relevant. Minus 25 is equal to 1/2 of 10 times v squared, and then you solve for v squared. So that's 300, 275, 4, 550, 55 equals v squared. And so it's the square root of that, whatever that is, 7 point something. Okay. Good question. You will see questions like that. I'm pretty sure there are multiple choice that are very similar to these. That's true for all the free response. In older tests, there were multiple choice questions that were like the free response. So be on the lookout for this, because I've gone back to those. I want y'all to do those tomorrow for me. The carts that come up and down, and the work energy problems, either on an incline or on a flat surface. So be on the lookout for those problems and be prepared to do them. All right. What else, y'all? Okay, fall 2020, number 3. Okay, you're going to have some of these, right? This is going to be on your free response in a couple of weeks, so it's definitely going to be in the quiz. The speed of the ball at point C. Also recognize that at point A, that not only does it have a height, but it also has a speed. Whenever I do these, I always start just by labeling the type of energy. Excuse me. I have potential energy and I have kinetic energy because it has a speed. I just have to read the problem carefully to find out, is it moving or is it not moving? And then at point C, I know it still has potential energy because it's 2 meters, and it also has to have kinetic energy because some of the kinetic energy that was at point A has converted now into some of the potential energy at point A has converted into kinetic energy at point C. It's moving faster at point C than it was at point A, which, by the way, allows me to get rid of this answer, and I could probably get rid of C too, but I'm not sure. So I set those two equal to one another. I have mgh plus 1/2 mv squared. Both of those are at point A is equal to mgh plus 1/2 mv squared. In this case, I have m's on every term, so I can divide through by m, and then I'm solving now. So 10 times 5, that's 50. I did 10 times this number plus 1/2 of this number squared. That's 1/2 of 4 squared equals 10 times 2. This is where I got that number. That's the height plus 1/2 v squared. And then I'm solving for v. That's 50 plus 8, 58 minus 20. So it's the square root of 96 is equal to v. Is that right? Did I do that right? Square root of 76. 50 plus 8, 58. Oh yeah, 76. Thank you. Sorry, I shouldn't try to do math in my head, right? Y'all be careful too. Don't make those same mistakes. Don't rush. You should have plenty of time. 20 minutes should be plenty of time for this quiz, so you'll just take a big deep breath and take your time on it. It's just 10 questions. I think most of them are easier than questions we've had in the past, so 20 minutes should be plenty of time, right? Be plenty of time for 10 questions? I think so. And so square root of 76, I think that's 8.7. Yeah, 8.7. Okay, gotcha. That one's a more difficult problem because you have both potential and kinetic energy at both points. And so it's just more numbers to deal with. So
Previous problem, actually, you have to find the speed for v. Did you actually speed instead of using a and c?
yeah, of course. Yeah, you could have, since you know now the speed at point C, then from number 3, then you could say that the energy at B is equal to the energy at C. The only thing is that if you got C wrong, then you're also, like if you got number 3 wrong and then you use the calculation for 3 to work number 2, then you're going to get 2 wrong as well. So I wouldn't recommend it. Okay? But yeah, you could do that. That's always true, that the energy at any point is equal. Yeah, know what I mean? Mm-hmm. Okay. Yeah, so how much kinetic energy does it lose in this time? You don't really need the time. All you really need to know is what was the kinetic energy of the car. So you have to do a little bit of maneuver because I don't know the mass of the car. I know the weight. So I know that the weight of that car is 8,000 newtons, and that's equal to m times g. That means that m is equal to 8,000 divided by 10, or 800 kilograms. That's a light car. Oh, no, it's not. It's a mass of 800 kilograms. And if it's traveling with a speed of 12 meters per second, then I can find its kinetic energy, just 1/2 mv squared, 1/2 of 800 times v, which was 12 squared, 400 times 144. 58,000 joules. But you might have been inclined to put E as the right answer. And if you put E, the reason is that you used the mass to be 8,000, when really the mass is 800. Be careful, watch those words, okay? Mass and weight are two different things. The weight is the gravitational force. The mass is the amount of matter, or even the amount of inertia that an object has. Words are important, okay? Don't do that very often, but if you see, I think that might be the only problem where I do that. Is that right? I think it is. So just be on the watch out for it. Look out for it. And then I think, Abby, didn't you have a question? Or you want me to do a different one? Number 7, okay. Okay, so I have trailer X with a mass of 500 kilograms and trailer Y with a mass of 2,000 kilograms. All right, and I want to know the ratio of the kinetic energy of Y to X. So I want to know what is the ratio of kinetic energy of Y to the kinetic energy of X. I just think I had this problem that year. I mean, I like these because they just come up on standardized tests like the MCAT and others. That these ratios where they ask this, it's a little bit different wording than we've done in class, but it's still important. I know that the kinetic energy is 1/2 mv squared and 1/2 mv squared. So it says that the speeds are the same. So I don't need to be concerned about the speeds. Those are the same. Just I want to know what is the ratio now of the masses. And the masses are 2,000 to 500. If I divide through both sides by 500, that is a 4-to-1 ratio. That just means that object Y, which has 4 times the mass, also has 4 times the kinetic energy. That's all I'm saying. That it has 4 times the kinetic energy because it has 4 times the mass. But I do know that a lot of you are going to take standardized tests. So I want you to sort of be practicing that. Okay? Do you have another one too? No? Abby? We went out to Lake Fossey Point today. Ever been out there? It's beautiful hiking. There's a 3-mile hike. That's where I was today. Yesterday was a 2-mile high all day. All right. Let me erase this. Number 11, you said. Okay. Probably going to see a spring question tomorrow. I drop a ball from a height of 10 meters, and it goes onto a spring. It says that that spring, this distance is 10 meters. That's height. And when it falls onto the spring, it compresses down to a compression of 2 meters. Drop this ball. Oh, there's 2 numbers in there. Huh. That was just a typo. Do you know which one it is? Is it supposed to be 10 or 20 meters? 10. All right, let's assume that this is supposed to be 10. Y'all see that I drop a ball from a height of 10 meters, and it says I drop a ball from a height of... Oh, okay. Yes, okay. Yes. All right. 2 ways you can approach this. Like, y'all might like this first approach. I'll do it. But it's kind of the clunkier approach. I could say that if I drop it by 10 meters and it compresses by 2 meters, then I could say mgh equals 1/2 kx squared. And notice, oh, actually, no, can I do it that way? No, I can't do it that way. Let's do it this way. This is easier anyway. Look, I'm taking my height from 10 to 20 meters. That means I'm doing what to it? Increasing it by a factor of 2. So I'm doubling my height. So what must I do on the other side in order to also get a factor of 2? Now k is the same because it's the same spring. So what must I do to x in order to double the right-hand side of that equation? I'm going to multiply x by what? Not 2, no, because if I multiply it by 2, that would quadruple the right-hand side of the equation. If I multiply it by 4, it's going to 16 it, whatever that word is. Not 1/2, that would be 1/4. What do I do? Somebody said it over here. I think it was you, Juliana. What is it? Square root 2, right. So if I root 2 it, if I multiply it times root 2 squared is equal to 2, right? The square root of 2 times square root of 2 is equal to 2. So that means that when I double the height, that x is going to increase by a factor of square root of 2. So I multiply the original x, 2 meters, times square root of 2, and then that's going to be my answer. So I think that, yeah, that's 2.8. E is the right answer. That's difficult because we don't usually see that. Like usually we'd say, what happens if you double x? But now I'm asking, what happens if you double h? If you double h, it's going to increase the compression by a factor of root 2. Still a quadratic equation, it's just I flip the numbers around a little bit. Okay? These are great questions, by the way. They're difficult in their own way. Mia? Mm-hmm. Did that answer your question, though? 5? Yeah, okay. 5 on 2017. Okay, so this is a similar question. Kinetic energy, remember, is 1/2 m. Okay, can I go and do this one anyway? And so if I double the velocity, I double this, that means I'm going to quadruple the kinetic energy. So let's go to 9 here. How much work does it take to make a 20 kilogram wagon speed from 2 to 4 meters per second? So remember that work is equal to a change in kinetic energy. So that's our work energy theorem, right? So however much my kinetic energy increases is how much work I've done on this object. So I can take the kinetic energy final minus the kinetic energy initial. That will be equal to my change in kinetic energy, which will also equal to the work, which is what I want. That's going to be 1/2 of m 20 kilograms times v final, that's 4 meters per second, squared, minus 1/2 of 20 times 2 meters per second squared. 10 times 16, 160, minus 10 times 4, 40, so 120 joules. I want you to just be aware that this is not, I'm going to write it in a different way that's not the same. That some of you might want to do it this way, but it's not the same. If I wrote it as 1/2 of 20 times 4 minus 2 squared, not the same, right? Y'all realize that? That's not, I can't distribute it that way. If you wanted to distribute it, you could say not 4 minus 2 squared, but you could say 4 squared minus 2 squared. That would be the same. But if I did 4 minus 2 squared, not the same as 4 squared minus 2 squared. I'm not sure if that was a mistake that you had made, but that's a mistake that some students would make. But back to the basic problem, I just want to find the change in kinetic energy. And the change in kinetic energy is that KE final minus KE initial. Is that okay? All right. Juliana? It's not on the equation sheet. Yeah. I mean, I don't even really think of it as an equation. It's just a thought, a theorem, right? So my work is equal to my change in energy. So, yeah, make a note of that. There are some other equations that are not on the equation sheet that you do need to know. Let me just write those down. FW equals mg. F is equal to mu times the normal force. You need to know your, well, no, you don't really need to know your trig functions because you're not doing any vector math. You might, if you have a 3, 4, 5 triangle and you don't know how to find the hypotenuse, you need the Pythagorean theorem. But I think everybody knows the 3, 4, 5 by now. Oh gosh, what else do you need? The work equals change in kinetic energy. I think that's it. Yeah, because you don't need kinematics, do you? I don't think you did. I don't think you needed that at all. Okay. But chapter 7, we're going to get back into kinematics, so that'll be fun and exciting for everybody. Jacob, did you just shake your head? Yes, you did. I saw you. All right. What other questions y'all have? Yeah. Hmm. Oh, you're not on your quiz. Really? Okay. Yeah, this is a momentum problem. Not on your quiz tomorrow. You're right. So this is 2019. Oh yeah, why did I even put that there? So it's this one, right? And it's like I went out of my way to put it on there too. The 2019 number 10. All right, I'll remove it from that chart. But you will need to know it in a couple weeks. Okay? But don't worry about it for tomorrow. Okay. Somebody, what else? Yeah. Patty? Okay. So this is similar to one that we did before, but I think it was the free response that we had done before. I think it's pretty much the same as that one, actually. Good question. Let's take a look. And draw a little picture just to help us think about it. The slide is 2 meters high and 5 meters long. That means that's the surface of the slide, which is the 5 meters. 4 meters long. Yes, thank you. 4 meters long. Now, can I take this right quick? My son's truck is in the shop. Hello. Hey, how's it going? Yeah, I'm good. Yeah. Uh-huh. Okay. Okay, yeah, I appreciate it. Okay. Did you check the other ball joint? Oh, okay. All right. So how much was the ball joint just by itself? So if you have to do the other one, how much was that? Okay. All right. That'll be tomorrow, you think? Or yeah, yeah. I just really want to. I don't want it to happen when we on the highway or whatever. Okay. All right, man. Well, I appreciate you. Okay. You think you'll call back today or be tomorrow? Okay. Yeah, I think so. Let me talk to my wife about it. Uh, okay. The other front end parts are okay. Oh, I got you. Okay. All right. Okay. Let me talk to her about it. We'll get back to you. I'll just talk to you. I'll just talk to you tomorrow. Okay. Is that right? Okay. Thank you, man. Bye. Whew. Okay. Sorry, y'all. My son's truck is in the shop. He didn't have an accident, just a ball joint broke. But $700 for a ball joint. Any of y'all want to put a ball joint in that truck for me? I know it's crazy. Anyway, sorry about that. So the slide has a frictional force that acts on the entire length of the slide. How fast is the kid going when he reaches the bottom? So he has potential energy at the top. He loses some work due to friction along the way, and then he has potential energy or kinetic energy at the bottom. So I would write it just like I did before, that he starts with a certain amount of potential energy. At the bottom, or excuse me, you can do this in different ways. I would do it like this. He loses some work due to friction, and then that becomes the kinetic energy that's at the bottom. So potential energy, that's mgh, 10 kilograms times 10 meters per second squared times the height, which is 2 meters, minus the work done by friction. That's going to be 5 newtons. That's the frictional force times 4 meters. That's this distance. That frictional force acts along that. And that's equal to 1/2 of the mass, which is 10 times v squared. So that's 10 200 minus 20, that's 180, 360, 36 is equal to v squared. And so 6 is the answer, square root of 36. All right. I forget who asked that. Is that okay? Yeah. Good question. You'll be looking at one of those, at least one, because I want to prepare you for the free response coming up in a week or two. All right. Other thoughts, y'all? Questions? I've had good questions today. I appreciate that. All 20, number 4. Okay. I think this is another one of those. Yeah, so this is another of those work energy theorems. So you can have one that's on an inclined plane, or this would be another type of that problem. Just like the one that we worked before, I have this cardboard box. It's sliding across the floor with a certain velocity, 2 meters per second. And then as it slides across the floor, there's a frictional force that acts upon it and causes it to slow down. And I want to know what distance does it cover before it stops. So it starts with a certain amount of kinetic energy. It loses the work due to friction, and then it ends with no energy at all. So all that energy that it had is taken away by the frictional force. So it's going to be 1/2 mv squared minus the frictional force times the distance is going to be equal to 0. Now, you have to do a little work here in order to find the frictional force, because I only tell you the coefficient of kinetic friction. So to find the frictional force, I know that that's equal to mu times the normal force. Because this is on a horizontal surface, the normal force is equal to the weight. It has a mass of 3 kilograms, so the normal force then is equal to the weight, which is 3 times 10, 3 times g, which is 30 newtons. So it's going to be 0.2 times 30 newtons. That's 6 newtons. That is the frictional force. I've seen students in my office where they just use mu as the frictional force, but realize 0.2, not your frictional force. That's your coefficient of kinetic friction. Okay, so I have 1/2 of m, which is 3 kilograms, times v, which is 2 meters per second squared, minus 6 times d is equal to 0. So that's 1/2 of 6 minus 6d is equal to 0. So d is equal to 1 meter. All right. You could have, if you were clever with that, if you didn't know the mass, I do want you to recognize that I don't think I do this in any of the exams, but instead of putting 30 newtons here, I could have put mg instead of 30 newtons, and then I would have had 0.2 times mg, and then the masses would have canceled out. So I didn't really need to know the mass, but I gave it to you, so that's why I went and just plugged it in. I do that? Okay. But beware, you don't need to know the mass. That it does cancel out of this because it's in every term. Okay. Be careful of that. Is that mean? It's not mean, is it? It was a mean question? I don't think questions can be mean. Like, people can be mean. Okay. There are different ways that you can approach it, but you always have to approach it from this energy perspective. Okay. Yeah. Yeah. That's the way we did it here. It's okay. You had them rearranged a little bit differently, but it's okay. Well, because your mass canceled out, so you would have had 1/2 of 4, 2 minus 0.2 d or something like that. Okay. Yeah, because your mass canceled out, which really was a more clever way to do it. Yeah, good job. Yeah. Yeah, because I know that all of the energy that it has is being taken away by the frictional force. So I could say that all the kinetic energy that it has is equal to the work done by friction. But recognize that's the same thing that I wrote over here, right? don't think of it as an equation. Think of it as the work is equal to the energy. I know that is an equation, but that work acts to change the energy. That's why it's not even on the equation sheet, because I don't really think of it as an equation. Okay? Thanks, y'all. Anything else? Okay. Okay, this is a good basic spring-loaded question. Um, not a loaded question, it's a spring question. So I have this spring that is compressed by a certain amount. I don't know what it's compressed by, but then it shoots the ball and gives it a certain velocity. What I do know is that all of the elastic potential energy that was in the spring is converted into kinetic energy. And that's sort of my guiding principle, that all of this energy that was in the spring is converted into kinetic energy. And now I want to solve for x. Notice I have m right here, that's m. This is k, that's the spring constant, and this is v right here. I can cancel out the halves, that's nice, and I get 250, that's k, times x squared is equal to m, that's 0.02 times v squared, 30 squared. So 0.27 meters, which is 27 centimeters. I don't know why I had it in centimeters, but that's what I had. So you do have to convert it. But 0.27 isn't on there. So when you saw that it wasn't on there, you should recognize that the units are different. Okay. And then 10 as well, you said? Um, oh yeah, so I gave you a hint here that you first want to calculate how much the spring compresses and then find the force. So two things happen. I have this box that falls onto a spring. That means that all of the gravitational potential energy up here is turning into elastic potential energy here. So I say mgh equals 1/2 kx squared. And then I solve that for x. So 1.5 times 10, this is the mass, this is the height, times 2 equals 1/2 of k, which is that 1.5 times 10 to the 5th times x squared. And then I solve that for x squared. Does anybody know what x is in this case? Huh? 0.02. So x is equal to 0.02 meters. But then I need to find the force. And so that's the second part of this problem, where to find the force, I say that that's equal to k times x. And k is that 1.5 times 10 to the 5th times 0.02. So that's 3,000, I think. Isn't that the right answer? Yeah, 3,000 newtons. Two steps. That's why I gave you a little hint. You first do that energy problem. The gravitational potential energy is equal to the elastic potential energy as it goes down. And then you find out how much it compresses, and then you can determine what is the force that's acting on the spring. It's going to shoot back up, right, because the force on the spring is a lot bigger than the weight of the object. So it's getting ready to coil back up. But I just want to know, what is that force? Okay. All right. Is that all for today, y'all? Okay, don't leave. I have a few of you that I didn't get, so make sure that you see me.